Okay, so I'm Nil Ortiz, and with me is Calvo, and we will be presenting OpenUEBA. It's a framework to do some user and entity behavior analytics. And as the name it implies, it's an open source framework. But before we start, a little bit of introduction of where we came. Like, we are working on AI+CTI. It's a foundation for nonprofit and innovation center. So basically, we do research and innovation on a lot of topics. And well, these are mainly our areas of research. Like, we have a lot of 5G, cybersecurity, artificial intelligence, blockchain, but we also do some other kind of projects like virtual reality, or right now we are delving into the new space area. And mainly these projects are motivated from public collaborations with administrations within the European Commission or private companies. We try to expand as much as we can and foster this kind of innovation ecosystem, so the technologies can reach all places. Well, this is a little bit the team that is involved in this project. As you will see, I don't look like on the picture, but it was taken a long time ago. And now a little bit about the project. So OpenUEBA, as in the implies, it's open, and it's one of the keys of our project, because we've seen that sure there are a lot of UEBA solutions and projects, and basically almost any technology is integrating UEBA technologies, but it's always into this kind of black box where you don't really know what's going on inside. You don't know how anything is being calculated. They just tell you it's using artificial intelligence and that you should just trust it. But it's very hard, especially in the cybersecurity context, to really assess if this output that the AI is giving you it's actually correct or not, because it can actually lead you to misinterpret or to apply the wrong mitigations or the wrong solutions to your problems. So for us, it's very important also, because since AI is being kind of the key word that floods every product, every technology, everything right now is working with AI, and being able to have it exposed and that anyone can just go and check the code, see what's the logic behind the heuristics and how it actually works. It really helps building our trust with the output of this AI. Plus, we are also integrating the cyber threat intelligence key. That way, we are kind of deviating from the usual model where all these tools that usually works with AI, they just focus on detecting anomalies or seeing variations on a specific time scale, or even just implementing some threshold rules. But we go beyond that and insert this part of threat intelligence that we will see a little bit deeper later. And now to talk about the AI part, I will leave the floor to my colleague, Albert.
Okay, so thanks, Neil. So I will present a little bit the framework that we are working on. Okay. So mainly the framework that we presented today is focused on user and entity behavior analytics, which is targeted on monitoring the user behavior to detect anomalous activities and highlight malicious patterns. So in marketing, behavioral studies has been done for years. So based on the analysis in which helps the customer stops, for example, it is possible to predict if the customer will purchase a certain item, or we can offer them personalized discounts. This behavioral analysis can be applied into the cybersecurity domain. Analyzing the baseline user behavior, we can highlight deviations from the normal behavior. So let me give an example. If a user sends periodic emails to all coworkers, it could be a normal activity, saying it is from human resources. But if another user, for example, from the deep team, has this kind of activity, it can be flagged as anomalous. To this end, it is conceptualized to build a framework for behavior analysis. Mainly, the framework is divided into three different components. The user profiles, the user profiling, so the multimodal sources are joined into a feature vector representing the user behavior. The threat profiling, so from the different threat intelligence sources are extracted indicators, which represent the different attack vectors. And finally, the risk calculation, which computes the alignment between the user profiles and threats. So in detail, the main benefits of our proposed framework are the following: the efficiency, so the ability to scale up from small scenarios to complex institutions with thousands of hundred entities; transparency by design, so the framework is built using the principle of transparency. So to this end, it will be open source, allowing third parties to modify the software as they need. And standardization, so we use STICs and CAPEX frameworks to represent and share threat data. Okay, so to build and evaluate the OpenUEBA framework, we have access to a real-life dataset. In detail is data from a local university with around 20,000 users, including students, professors, and staff. In detail, to perform the first version of framework, we take into account the following multimodal sources. The network data, which is information captured on premise hardware; endpoint data, which is information captured using an agent; and application data, which is log data or forward data from a CM. Okay, so the user profiling steps allows the extraction of relevant information from sources and structure them into filter vectors. So here, to perform this analysis, we use autoencoders, which allows us to build representations of the different data sources, and after that are merged into the same filter space. These representations allow us to compare the user behavior at a certain moment against the historical behavior, and also the comparison against similar users in the organization. So next model that we are presenting is the threat profile that is targeted to extract and structure knowledge from threat intelligence sources. Here, what we want to compute are mutations, which are deviations from known threats. So we compute these mutations using historical data from threat intelligence sources. So, for instance, the indicators of a phishing attack are the following. The user receives an email with an attachment, then the user extracts and opens a Word document, and finally enables some macros. The proposed mutations, note the skill chains, are the following. So the change uses a similar indicator. In this case, it receives an Excel or transformation tool. where some optional indicators are missing. And finally, the transformation tree, where some parts of the data vector are replaced according to historical indicators. Well, so the final step of our framework, it could be the alignment. So we align the user profile with the different attack vectors that we compute in the threat profiling model. With this, the output of our framework is a score where for each user, it is calculated the exposure to new threats. As well as we can see here, an example of the output. So now Nil will explain an example of how the cyber threat intelligence can be applied to behavior analysis. So Nil, the floor is yours.
Mm-hmm. Yeah, thanks. Yeah, so how do we apply this threat intelligence into our platform? Because there are many ways of consuming threat intelligence, right? You can just take your IOCs and feed them to the CM or just do reports. But in our case, we are interested in more than just IOCs. We are also interested in the TTPs and the indicators of attack. So to detect this behavior, we go one level higher on the pyramid of pain. That way, even if the indicators of compromise change, we can still correlate the same behavior of some pattern or some attack to the same kind of threat actor, or even to detect similar behaviors. So in this case, we gather threat intelligence from multiple sources. It could be like FireEye, Recorded Future, and these kind of premium sources which have a high reach intelligence about how some malware operates, or how a campaign is set up, or even how a threat actor kind of works, and all the tools that it uses. And with this, we feed it to OpenUEBA using sticks as format. And when we have it on OpenUEBA, we use it to do the threat profiling. That way, we can perform a model of the threat that we are trying to match with the model of the user profile that it's being monitored. That way, we can see if the activity of one user kind of resembles or it's similar to a specific threat. And of course, the way detection of monitoring usually works in cybersecurity is that whenever you see an indicator on your environment, then you just raise a flag. But in here, we don't really need to have the full spectrum of the attack, or even have all the steps being successfully seen. This way, if we see that some user has a behavior that kind of resembles some attack, like maybe he's just performed 80% of the actions or 60% of the actions that the threat or the malware or the phishing campaign usually does, we can already assess that this user has a high risk towards this kind of threat. And we can even use our knowledge that we have observed of this user prior to the actual events that we have seen to enrich with further observables our previous threat intelligence, right? So if we've seen that some phishing campaign usually uses certain domains, but in this case, we see that the user followed every step, but instead of receiving a mail, he got into this domain from a Teams link or some iCalendar invitation, we can also add this into our threat intelligence and enrich it even more. And well, even further, we can add also mutations to non-threat actors using IOCs from other feeds, like you would have on your MISP or your Taxi or your Yeti or any other platform that uses this kind of feed aggregators to benefit from the intelligence. And well, let's see, for example, in this case, well, we have the behavioral model of WannaCry. I hope you can see it properly. But for example, in here, we have detailed every step that WannaCry is usually performing. So we see the name of the services that it uses, the name of the processes that it uses, which commands it's using with each process, what kind of actions each process is performing, and what kind of traffic this WannaCry it's generating. So in our traditional CM or antivirus or any kind of standard solution, we will have to detect something specific from these three. But in our case, whenever we see a certain amount of steps of this workflow being actually processed, we can already raise a flag and say, hey, this user, it's kind of behaving like WannaCry. You might want to look into it further. And even if tomorrow this model were to change, and instead of using a specific process or instead of using Samba traffic, it were to use another protocol, we could also just tweak this model very quickly and adapt, or we could maybe even detect it directly from our environment and already enrich it further into our system. And of course, as everything, this can also be modeled into the Direct framework. This gives us a huge context to be able to actually track and map every single of these steps into like a proper framework. And this way, it's also very easy for companies and for pretty much everyone to integrate and be able to extract context out of every single step, right? You don't need to know exactly what everything it's actually doing. Like you don't need to know the exact command or the exact process, what it is, but you already know that it's related to a specific task of the Mitre attack framework. And this way you already have a very clear view of what's happening. And for example, this could be the same information as we've seen before, but in a graph. Like in this case, we have a very standard or a very small sample of the IM DDoS model. So this was a DDoS service that was running, it was pretty popular like 10 years ago, but it kind of uses a pattern that it's adopted by many other DDoS services nowadays. So in this way, we only have, for example, that generating to some C2 traffic, that it has a specific threshold on the traffic and a specific threshold on the instances, and we could have some indicators of some infected host. But translating this to the behavior, if we see some connections falling within these thresholds and following this pattern, we could already say that it's similar to this and start enriching this model even if we if we start from something very, very small, right? And in the end, like this could be a representation of some tool or some malware. In this case, is Poison Ivy, that we have a lot of intelligence. For example, on this one, it's one of the most well-documented malware tools. So we have many indicators. We have a lot of information about it, and this gives us a representation of what we should see on our network. And of course, we will never see like all the hashes or all the samples, because it's not realistic, right, to see it. But maybe just seeing similar behavior to this already can give us a pretty good understanding of if the user is or might be at risk of this kind of tool. And now we'll speak a little bit about the ecosystem that we are building. So this is, as we said before, this is not a specific tool or kind of a script or a software that you can just install. This is a whole framework. And in this case, we're using the Elastic Stack with Kraken as log manager. And on the AI engine, we're using Flask, MLflow, Keras, many AI technologies. For the intelligence platform, we're using OpenCTI to store all of the intelligence information. But this could be exchanged with any other tool that you use for this purpose, as long as it uses the same kind of format on threat intelligence. If it can handle sticks, you can plug it into anything else. For asset inventory, for example, we're using OpenNAC Enterprise, which is from a company named Open Cloud Factory, that we're partnering with them to develop this framework. We're also, since AI really needs some historical data to function properly, we're also developing a ticketing system collector, which would extract, doing some natural language processing, will extract information from past incidents that you have on tickets that usually most ticketing systems just have the information on plain text, and you don't really have this kind of a standardized fields, or in case you do with like the Hive, then you could feed this data directly to the core node that it's actually kind of the keystone of the framework, and the one that handles all the analysis being done between the AI engine and everything stored on the log manager. And well, this is just a little preview of the UI, what we could see, like just logging into onto the framework. You will see already like the group of users that are the most at risk, the threats that are affecting you the most, a little bit of threat clustering of the current threats on your network. Also, another way of searching for different threats or different groups within your network here. When checking a specific group, we would see a graph of the activity of the group of users. How do they relation between them? What's the relationships between other groups of users or between the users themselves? And a little bit of kind of a first glance view of what's the state of this group of users. And similar, we could see the same for threats, like which group of users are most affected for this threat, and see multiple KPIs, see graphs of activity of the threat and how the threat behaves. And well, basically, right now we're also trying to build a community based upon this open model, since we see that one of the main issues that we find when trying to work with like solutions that use AI from the cybersecurity domain is that the people specialized in artificial intelligence, of course, have no idea of cybersecurity, and the people specialized on cybersecurity have no idea of artificial intelligence. So this framework is also a tool to help both sides to kind of join and work together. And since it's open source, both sides can see and try to understand what's being done on the other side. Well, this is a little contact reference if you wanna try this framework and schedule a proof of concept with us, or directly join our team. We're always looking for people, not only on the cybersecurity domain, but we have many other areas where we're looking for people. Or even if you're doing some master's degree or some PhD and you want to perform the thesis with us, you can send us an email to contact@openueba.org. And this will be it for the talk. Thanks for everyone staying here. If anyone has any questions, we will be very happy to answer anything.
Yes, great. Thank you, Nil and Albert. While we give a couple of minutes for people, again, attendees or people in YouTube that want to send you a question, again, Slack or here at Zoom. I have a question, actually. This is really interesting, and actually was an area that I was investigating back then. I was actually wondering, you say that your solution basically requires a network agent, right? On top of, an agent like OS Query that runs on a computer, right? Mm-hmm. How would that work in a cloud environment where more than, again, analyzing user in the sense of, physical users, but you may want to analyze service accounts or users within servers, but in a cloud environment, like, again, admin or root activity or accounts that are, not proper human beings, but and then again, I was mentioning the network part because I feel like that's perhaps the most trickiest part in cloud to get that kind of information. So I'm not sure if you have this use case, if you thought about that, and if there is any, any way that we can do the same.
I mean, we're not treating right now this kind of use case, but the agent, the sensor, it's like one of the main ways that we extract information, because it's kind of our current means. But the idea is that you can input almost any kind of information about user activity that you have on your system, like the same way you would do on your CM. If you can analyze these logs on the CM, you can just forward it to the Elastic Stack that we're using, and we'll perform kind of a similar analysis. Maybe you will have to do some feature engineering to alter the fields that you're using to comply with the Elastic Common Scheme that we chose to use to keep on the standards for Elastic Stack. But yeah, I don't think it would change that much, since the same models can be applied to kind of I don't want to say everything, but kind of in this context, yeah, it would be the same, really, because we're also doing not only analysis on humans or as users, but also entities within the network. That could be server accounts, or maybe just a script that it's doing the same actions every day, and someday you see it deviating for some reason. I don't know if this answers your question.
No, absolutely. Again, my area of expertise back then, my area of research was more about how could I identify, behaviors in servers, mostly from admin activities, right? Because if I get someone into my server as a root account, I understand that a legit admin would perform a typical set of actions, right? I don't know, running a specific set of commands. They could be ls, pwd, whatever, right? But if the same user start using, and then I cluster together those commands and say, okay, these commands have some kind of like weight. And I'm like, okay, if you use, I don't know, pwd, ls, and, you name, in ID, or uname, in a specific time frame, it has some kind of like, it's a behavior that I may be okay with, and I assign like a weight. But then if in between someone run, I don't know, PS, right, or run like a netstart or like a NC, then I definitely want to flag that. I really want to flag that because it kind of like the admin is going outside the behavior that I would expect. And therefore, and that was mostly about, but this happens in the cloud, right? And without having pretty much no network visibility, it's quite expensive to have that type of, data in the cloud. So again, I was also thinking if, I guess what your answer was about is that as long as I comply with the format in the Elasticsearch stack, the model is trained to work on that data. So as long as I provide them that type of model, I should be good, in anything, right? So then at that point would be me to create some sort of like transformation data in layer in between, right? To then prepare the data for your platform, if I understand correctly then.
Yeah, because in this case, you would detect it with a simple anomaly model.
Yeah. Mine was a very simple use case.
Yeah, our point in here is mostly focused on not only doing this kind of detection on anomalies on user behavior, but also introducing the threat intelligence aspect and mapping these behaviors into threat behaviors to also give more context. And also, this is something that's sometimes overlooked, but in real world scenarios, you rarely see or have all the logs and all the data that you would like to have. Even if you are actually logging it, most of the time, it doesn't reach the cybersecurity areas, since forwarding and storing logs, it's really expensive. And this way, you don't really need to see the whole pattern or every indicator to assess that something is a specific threat. If you see that the behavior kind of resembles what you are expecting to see from a threat, you can already tell that it could be affected by it.
All right. Yeah. Thank you, guys. I don't see any questions so far. So what I would do is, again, if you still have any question, you can write in Slack. Albert and Nil are there. I would thank you guys again for having this talk. It was cool, interesting. I really enjoy it.